So the key learning is and because there's all kinds of uncertainty that happens, right? All kinds of new things that come in, right? There's this book, we've already read a couple of chapters from this, Strategic Management of Large Engineering Projects, relatively small book by Roger Miller and Donald Lessard. Wonderful book, right? Really, they've studied about 65 odd mega projects from across the world, oil and gas, water, transportation, petroleum, and sort of synthesized, what some of the key risks are and what to do, right? So certainly anyone interested in project management, sort of a must read. But what they talk about is they say, look, over a period of time, projects could face natural uncertainties, right? So it could be climate change, it could be earthquakes, it could be whatever, sea level rise, you name it, right? So there could be natural uncertainties that fundamentally affect that infrastructure. So a coastal road may be submerged at some point if sea levels rise. Okay, it may not be a road at all. You might write a contract till 2048, but by 2030 there may be no road, right? So there are natural uncertainties. Right? There are all kinds of market and economic uncertainties, right? The demand might go up, might come down. I don't know what the future of roads will be, since we're taking that example, right? Because telecommunication infrastructure is getting better and better. Will we need to commute, right, as much as we need to, right? I mean, even today, I can get on a conference call or whatever and not necessarily need to physically meet somebody, right? So in the old days, you had to take a train, go to Delhi, sit for a meeting, come back. For a single meeting, it might have taken you a 2-3 day sort of effort. Today, I don't even have to go to Delhi for a meeting, right? I can just sit here, I can do my work exactly at the time of the call, I can log in for 45 minutes and I can come out, right? And going forward with augmented reality, virtual reality and all of this, maybe this just gets better. Maybe what happens in 15-20 years is we don't transport at all, right? Or the transportation demand reduces considerably because of increases in telecommunication and also ways in which people work, right? At one point, work was centralized, everyone came to one sort of location. Today, work is by nature decentralized. A lot of work happens over email, etc., right? So you have these kinds of possibilities, right? And therefore, what will that do to your transportation infrastructure, okay, is something to think about. Maybe the demand for that infrastructure goes down because of all kinds of market fluctuations, right? There could be all kinds of political risks that infrastructure could face. We know all about that. Industry, market are somewhat related, so I won't sort of repeat what I said. There can also be all kinds of technological uncertainties, right? So, Harsh was pointing out that, yeah, technologies could change. Again, to take the road example, how far are we, do we think of actually developing, vehicles that don't necessarily need to go on the ground, but can actually hover at some sort of height in the air, right? Because essentially one of the reasons traffic is congested is because we're all using the one lane, right? If we're at some point able to invent devices that can actually hover, then you actually have airspace that you can use and you can decongest. Today it sounds like science fiction, right? But today's technology sounded similar science fiction 30 years ago, right? So again, will this happen? Will it not happen? We don't know. But the point is, as technology evolves, there is a chance that what you have today might become redundant, right? So today maybe we are dependent on thermal power for a lot of the country's needs. So we have to build these relatively expensive thermal power plants, spend a lot of money on importing coal and so on. But also we understand that over a period of time, our ability to generate energy from solar is sort of becoming far more efficient, effective, cost effective, all of that, right? So over a period of time, we might find that thermal energy doesn't need to be a source of energy at all, right? But you've still built that plant and you need to get a return out of it, right? So there's technical uncertainty. So the point is, the world does not stay the same, right? All of these things keep evolving, okay? And therefore the project agreement cannot stay the same as well, right? So it needs to keep evolving, right? I don't know if you can recognize these. Anyone recognize these two gentlemen? Okay, the one on the top is Professor Oliver Williamson. He's a professor of economics at the University of California, Berkeley. About 10 years ago, I like to think 2008, but I might be wrong by a year or two, he won the Nobel Prize in economics, right, for something called transaction cost economics, which is sort of a theoretical framework that he developed. I mean, sort of others had also said similar things, but he'd sort of really augmented that framework. And below is Professor Oliver Hart, who was at Cornell, who also does research in similar areas. But yeah, so this is Williamson from Berkeley. He won a Nobel. So they said, and this is something that I picked out of one of Williamson's papers, so that's why it's in inverted commas, right? So he says, long-term contracts, okay, and our infrastructure projects are long-term contracts, executed under conditions of uncertainty, and our projects are executed under conditions of uncertainty, are ones for which presentiation, which is a word that means the ability to foresee all eventualities in the future, right, is expected to either be prohibitively costly or impossible, right. It's either not doable, right, over the long term, you just can't foresee all the eventualities because there's so many and they're so uncertain, or in order to do it, it's just going to be extremely expensive, right. And therefore, cutting to the chase, a different kind of contracting relationship needs to be determined. So, you can't have the sort of, okay, I agree that you do this and you agree that I give you this for a 30-year period, right, because the terms and conditions of what we are working on might not stay the same, right. So, essentially again he says a lot of uncertainty, you can't have these kinds of rigid contracts, right, you need flexibilities, right. So, the moral of the story thus far is we have, and so these are what they call, so these are what he calls incomplete contracts, right, which means contracts that where everything is not filled in, where things can be changed, right, where the contract can be completed later on, right, and essentially incomplete contracts, therefore are contracts that have some amount of flexibility that you can actually change them, okay. So, the background behind the first paper, right, that was presented here is a paper which I wrote with a colleague of mine, Jessica Seddon, who is now at the World Resources Institute, but used to be an adjunct faculty here. The background behind that paper and why this fits in is some time ago, the government of India said, look, we had a bunch of PPPs that we executed, right. At one point, India was one of the world leaders in terms of the number of PPPs that we were putting on the ground, but somehow that has just dried up currently, right. We've had poor experiences with PPPs and people aren't really, governments or the private sector aren't really willing to come forward. Right. So, they set up a committee called the Committee for, I think, Revitalization and Restructuring of PPPs, or whatever the committee was called, headed by a very eminent personality called Dr. Vijay Kelkar, right. And the Kelkar committee was asked to essentially go and look at stakeholders across India, understand what the issues with PPP were and what the country needed to do to revitalize PPP. So, revitalizing PPPs was a mandate of the committee. This was a few years ago after the Modi government came into power, right, the previous, in the last election. So, the Kelkar committee interviewed a number of people, among whom were Mr. Krishnan, Mr. Venkatesh, who was heading L&T IDPL at the time, and myself as well, right. So, and along with a number of other people who they felt had some knowledge on PPPs. And one of the things that Jessica of course, and one of the things that Jessica and I volunteered to do is we said, look, we'll sort of, I think one of the problems that you're having with PPPs, and this is not just us saying, a lot of people were saying it, is that your contracts are too rigid, right. Right at the beginning of the project, you guys spell out land acquisition should be completed, construction should start and finish here, you have 18 years of operation, this is sort of the demand that you expect and this is therefore the money that you will get. At the end of the 20th year, you will hand the concession back. I mean, you sort of seem to have a very sort of one way view of the future, right. And obviously, what experience is telling us is that that rigidity does not work, right. You say it could take a year to do land acquisition, it often takes more, right. You say it take X amount of time to do a construction, but often it takes more for whatever reason, right. We think the demand will be like this, but it may not be like that. Sometimes the initial demand itself is wrong, right, but sometimes the initial demand is what you predicted, right, but that growth percentage that you had in year 3, year 5, those do not come to be, right. So, your contracts are extremely rigid. And that's why these projects are running into problems, because somebody has sort of said they will work with this contract. According to the contract, they're supposed to make a certain amount of money, but in year 3 or year 4, the demand for that road dips, the toll connections dip, right. So, now that person is out of pocket, right. They have already paid the money to build the infrastructure, they are not able to get the loans to the tolls to repay the loan back. So, either they have to go and the bank takes over the asset or whatever. It's not a very happy scenario. Right. And because of this, the private sector again is reluctant to come forward, right. Because of this, the public sector is also reluctant to offer more of these PPPs, and essentially that's what you're seeing today, right. The investor confidence, the developer confidence, promoter confidence, everything sort of come down, right. So, the way to solve this is you've got to be able to put flexibilities into the contract so that the contract can readjust, okay. And then the question was, okay, that's logical. If you want uncertainty, if there are uncertainties, you will have flexibility, right. So, I mean, that's just common sense, okay. It's like saying, if there is a chance that it may or may not rain, you give yourself the flexibility of taking an umbrella with you, okay. If it rains, you can take open the umbrella. If it doesn't rain, and if you've got one of these really nice compact umbrellas that they make today, just stuff it in your bag and, I don't know, it's what, 300 grams heavier, but not really the end of the day, right? The inflexible approach to that problem is to wear your raincoat, right, or is to wear your duck pack raincoat, right, which is heavy enough that you can't really fold and keep it in, right, and if it rains, wonderful, right, you're dry, but if it doesn't rain, then you're carrying a 5 kilogram or whatever, I don't know what these raincoats weigh these days, it's something that you can't really adjust. So this is exactly the trade-off, right? So if you know it's going to rain, you're probably better off wearing the raincoat. You're probably likely to be drier with the raincoat than with the umbrella, right? Because the umbrella will always allow for lateral movement, or there'll be some driver who will drive by you, splash onto a puddle and it splashes onto you. So the umbrella is not foolproof, right? The raincoat is. So if you know it's going to rain, probably makes sense to have the raincoat if you know that the information is not going to change. But if there is uncertainty, if there's a 50% chance that it's going to rain, then you're probably better off taking the flexible solution, which is the umbrella. So it doesn't have to do with infrastructure projects, right? Uncertainty and flexibility are just common sense. If there is uncertainty, you have to have some flexibility. But then the question was, okay, all of this makes sense. But for infrastructure, what does flexibility mean? Right? And so that's where we said, okay, and this was explained in the presentation, there are 3 kinds of flexibility. We call them adjustments, options and settlements, right? So here's the thing, an adjustment is something that you pre-program into the contract, right? Where when a certain trigger exists, the contract automatically changes, right? Very simple example that we see in construction contracts is something that we call a price escalation clause. So you and I agree, right, when we wrote the contract that, the price of steel is, X, and so this is the rate for steel. You have so many kilograms of steel that you need to use on this project. So this rate multiplied by this quantity is your cost that I'm willing to pay you. But after we sign the contract, the price of steel goes up, right? Because the price of steel can go up because of all kinds of dynamics. So contracts often have what they call a price escalation clause, where they say, up till a certain band, normally 10%. If the price of steel goes up by 3-4%, automatically the contract will readjust. You don't have to say anything, I don't have to say anything, right? Automatically the contract readjusts and the amount of money that I should get paid will automatically go up, right? That's an adjustability, right? It's a flexibility, right? I'm not cutting ourselves down to one price, right? And then suddenly one of us gains and one of us loses if the price goes down or the price goes up, right? I'm allowing for some kind of flexibility. So that's an adjustability, right? So these are some examples, okay? So today when you look at what is the toll to be charged, right? If you go on a toll road, you'll probably be paying 45 rupees if you go by a car, 25 rupees if you take a bike, whatever. Every 6 months, these tolls get adjusted, right? They get adjusted based on inflation. Inflation is calculated based on things like the wholesale price index, right? So the wholesale price index will tell you what inflation is at the current time. If prices have inflated since the last time, tolls will automatically inflate. So after these corrections, you might have been paying 45 rupees the last time. You may now suddenly be paying 50 rupees, right? It's not something that we discuss or negotiate. It's pre-programmed into the contract, okay? And an adjustment automatically takes place, okay? What is the logic? The logic is that if inflation increases, the costs of materials are going to increase, your cost of maintenance is going to increase, and therefore you deserve to collect more toll. But rather than haggling over how much toll should I collect, we have a formula. The formula kicks in, okay? This is a very interesting one that they've used quite a bit in Latin America. It's called the least present value of revenue contract, okay? And this is simply how it works. It sort of says, okay, all of you are bidding for my project, all right? What we're going to do is, you're going to tell me, okay, what your expected revenue stream is over the course of this project, right? So you tell me, and what your expected cost stream is as well. So you might say, my construction wing thinks that it will cost me 300 crores to build this. I expect these kinds of revenues to come in over the next 20 years, okay? Somebody else might say, I expect this construction to take 280 crores. I'm a little bit more efficient with construction and I expect this kind of a cash flow with regards to revenue. So each of us submit a cash flow statement, right? These are my expenses and revenues from year 1 to 20, right? We all agree that we'll do it for 20. I supply a discount rate, 12%, right? I take each of your cash flows and I discount it by 12% and I arrive at what I feel is a net present value that you expect to gain out of this project, all right? So all you're doing is just sending me your cash flows, okay? I am doing the discounting using the same discount rate for all of you, and I'm saying for you the net present value comes to 100 crores, for you the net present value is 120 crores, for you the net present value is 150 crores, whatever, right? So I look at the person who is making the least net present value, or the person who is profiting the least from the project. And I say, you are the person who is most responsibly using public money, because you are trying to profit the least, right? So you take the project, alright. So I've given you the project under an assumption that you will make 100 crores of net present value of revenue, right? Now, although we said 20 years, I do not actually hold you to 20 years. I hold you to when you will make 100 crores of net present value of revenue, right? So every year you tell me how much you've collected and what your expenses are. And every year I will mark at the end of that year what is your net present value. Obviously, in the first couple of years you will collect very little revenue, you would have spent money building the project. So your net present value will be negative, right? Then slowly your net present value starts becoming positive, because every succeeding year you start collecting money from toll users. You only have maintenance, which is possibly, hopefully, less than what you're collecting. So your net present value keeps increasing, right? We keep going until you hit the 100 crores, right? If it turns out that traffic is far higher than expected, maybe you will hit your 100 crores in year 16 or year 17, at which point, at that point, I stop the concession, I take the road back and you leave, and you got your 100 crores. It could be that traffic is not as as expected, and therefore after 20 years your net present value of revenues was only about 80 crores, okay? In which case I allow you to continue to operate the project so that you get to about 100 crores. And normally, I can even define a band. I can say, look, I can reduce 5 years, I can go up to 5 years, but whatever, you can do it indefinitely, you can have a band. But what this does is that the contract duration automatically readjusts, okay? You're not saying anything, I'm not saying anything. Automatically, the contract duration adds a year onto it if the demand was not expected. See, today what's the problem? Many of these roads, right, the demand is not as per expectations, but still I have to give the road back after 20 years. So I'm going to end up with a loss on the return that I expected, right? I might still make some kind of a profit, but it might be a lower profit than I expected, right? So in order to sort of guard against that, we have this thing that says, let us dynamically extend the contract, but the extension is not a negotiation. We're not horse trading. Give me 2 more years, I'll give you 1 more year. None of that. We automatically extend by 1 more year if you've not met that target, right? We automatically extend. The moment you meet that target, whichever year it is, 17, 19, 20, 21, 22, the contract gets cut, right? So again, the contract is flexible, right? It accommodates scenarios where demand might be better, scenarios where demand might be worse, right? And allows the private developer in this case to make a reasonable return. You guys get the LPVR idea? So that's another adjustability. In other words, adjustabilities are changes that happen automatically, okay, on projects, right? The commercial operation date sometimes is inked in right at the beginning of the project, right? And then because of land acquisition delays, your construction happens much later and your commercial operation date is much later. So rather than fixing the commercial operation date, right, one could just say that commercial operation date is 18 months from the date at which land acquisition finishes. So irrespective of when land acquisition finishes, automatically a COD, a commercial operation date is set, right? So again, the contract automatically adjusts, right? So adjustabilities are automatic. They are if-then clauses that you put into the contract. If this happens, then that happens, and that's it. Neither the government nor the private sector can say anything about it, okay? Real options are a bit different, right? Who understands what a financial option is in the world of finance? Someone quickly explain to me what a financial, Harsha. Correct. So, yeah, so essentially the logic is this, right? I buy a share of, I don't know, some stock of company X, okay? I buy it at 60 rupees, okay? Now, if the price goes up tomorrow to 65, great, right? I can sell it, I can make a profit, okay? But my worry is that the price might go down to 55, right? In which case I make a loss, okay? So what I can do is I can buy an option to sell it at 60 tomorrow. Okay, it might cost me 1 rupee to buy that option, right? We won't talk about who gives you that option, all of that, right? Now, if it goes up to 65 tomorrow, right, I don't exercise this option at all. I sell it at 65. If it goes down to 55 tomorrow, right, I exercise my option and I sell it at 60, right? So if it goes up to 65, so either way I've spent 1 rupee buying that option, okay? If it goes up to 65, I've made a 5 rupee profit, 1 rupee I paid for the option which is now wasted, 4 rupees I've made my profit, right? If it goes down to 55, I sell it at 60, right? So I've made no profit, no loss, but I paid that 1 rupee to the option, so I'm actually -1. So it could have been plus 5 minus 5. I've now made it plus 4 minus 1. Right. So I've slightly curtailed the upside, but I've really curtailed the downside. So that's what we call an option, a financial option, right? There's what we call a put option, a call option, whether you're buying an option, whether you're looking at an option to sell a stock or an option to buy a stock, right? You might have the same option to buy a stock. So an option is defined as a right, but not the obligation, right, to exercise something, right? So by buying that option, you have the right to say, I'll sell it at 60. But you don't have an obligation to sell it at 60. If people want to buy it at 65, you sell it at 65, right? So real options are the use of that strategy in the real world, right? Financial options are in the world of finance, right? Real options are in the real world, right? So let's look at some real. So again, there was this example, I don't know which of you talked about it, was the parking garage, right? If you listen to the parking garage story, it's very similar to the stock story. Okay, so what is the problem? The problem is I want to build a parking garage, right? Today I have demand for 3 stories for sure, right? Demand might go up for 6 stories, okay? So I can build a 6-story parking garage today. I can spend all that money, but there is a chance that demand might not pick up, in which case I wasted money, all right? Or what I can do is I can build 3 stories today, right? But strengthen my foundations and my columns to be able to go up to 6 stories later. Right, thereby I am giving myself the option to build up to 6 stories, right, and there is no automatic trigger point, right, that says, okay, you go up to 6 stories. I now make a decision, right? I look at cars coming in and I find that, every day there are many cars parked on the street, therefore my parking garage needs to go up, and I go up 1 story, right? Or I find that the number of cars being parked on the street are increasing so quickly that I say, let me go up 3 stories. Right? So I now have a lot of flexibility, but it's now my choice. Do I stay at 3, go from 3 to 4, 3 to 5, 3 to 4, 4 to 5, 3 to 6? I mean, there are a number of permutation combinations, right? So that's an option. Again, there's a cost to that option. The cost was strengthening the foundation. So I paid a bit extra, right? If demand did not go up, then I've lost a little bit, but I probably lost less than if I had built all 6 floors. And similarly, when the traffic picks up, obviously, it's a bit more expensive to build 3 now and 3 later, because I have to remobilize form work, scaffolding, etc. If I had done it then and there, I would have gotten some sort of benefit. So going from 3 to 6, right, is a little bit more expensive than going 0 to 6 directly, right, but I'm able to time it better, right, I'm able to minimize my downside, right, and therefore that's what we call a real option. So it gives me, strengthening that foundation gives me the right, but not the obligation. Right. So it could have been that I never used that option. Okay. So that's the parking garage. There's this sort of famous bridge in Portugal called it was a bridge over the river Tagus. Right. So again, they designed this for road traffic, but they always had a feeling that road traffic may not really pick up, or after a while, road traffic may not really provide, revenues, and therefore they'd actually strengthened it to be able to take rail traffic. And at some point in the middle, when the concessionaire found that the road traffic was not really increasing to the level expected and they weren't getting enough revenues, they actually changed that bridge from a road bridge to a rail bridge. Right? So actually they re-engineered that bridge, and they actually built the piers and so on, such that essentially they could do that very easily, and started running freight on it, and all of that, the freight was of course paying for the use of that bridge, and freight traffic growth was much higher, and as a result of which, right, the project was actually in good shape, because if there'd only been a road bridge, the guy would have lost money because demand was not picking up, right? So again, that's an option. There is no obligation, unlike in the adjustment, right, where if inflation increases, your toll rate increases, right? There's no decision made. Here there is a decision. Option is given to somebody. That person needs to exercise that option, and they can exercise it whenever they choose to, right, based on whatever parameters they're thinking about, right? So in our desalination plants, for instance, we have these desalination pumps, right? So you can have a large number of desalination, pumps that pump in water into the desalination plant, and depending on the requirement of water, right, you can operate more or less pumps. So there's no need for you to constantly produce 100 mld of water a day if right after the monsoon season there's enough water and people are not really looking for desalinated water. Right? Whereas if you design a system that has to produce 100 mld a day, then you get to this situation where what do I do with all this excess water? Right? Whereas if you design it in a modular fashion, it gives you the option of saying, fine, let me produce 50 mld for a while. Then when groundwater gets used or whatever, let me start ramping up production, right? But again, it's not automatic, I decide, right? So that's what an option is. So you can put in options on infrastructure, right? Active options, passive options, we won't get into that. And then the third, so the first is adjustments, contracts automatically adjust. Second is options, it doesn't happen automatically, somebody switches the option on, but once they switch the option on, exactly what will happen is determined. Right. So if I go to any of these, so once I switch the option on, I go from 3 to 4 stories, or I go from a rail bridge to a road bridge, right? I can decide when to switch it on, but what happens when I switch it on is predetermined, okay? And then the third part of a flexibility is to say, look, not only do you not decide, when to switch it on, you also do not decide what happens when you switch it on. Right, and so you have these things like toll review committees. So essentially our presentation to the Kelkar committee was to say, you need flexibilities on projects, and flexibilities need to be of these 3 types. You could have some adjustabilities which automatically kick in, right? You have some real options that you give to various people on the project. Some could be vested with the government, some could be vested with the private operator. Let them exercise those options if the prevailing scenario turns out to be different from the anticipated scenario. Right? And then there are a set of flexibilities where, look, we can't even anticipate, right? We need to sort of have a way of bringing people back to the drawing board and redrafting the contract, right? Was essentially the submission to the Kelkar committee, right? And of course, their response review, you can go and the committee's report is online, and you'll find that, me being acknowledged in the first page and all of that. But the key thing is you've got to turn to page, 137 or whatever, where it essentially sort of says that even though, Ashwin and Jessica or Seddon and Mahalingam or whatever they say, etc., who says the problem with flexibility is that how do you know, right, that the flexibility is being used wisely? For instance, if we say this least present value of revenue, right, the lesser revenue you're making, the contract will extend. How do you know this crooked guy is not giving you doctored estimates of traffic? Maybe he's making X amount of money, but he is showing only 50%. Right, he's collecting in cash, he's not giving receipts, etc. So how do you sort of monitor that, right? So every time you put in a flexibility, right, it has to be used wisely. I mean, you have to have trustworthy people to use it. Otherwise, this guy is nicely milking sort of a cash cow, but representing that it has lower cash revenues, he's getting more and more time to continue to milk it, right? So how do you govern all of that, right? What is the mechanism? And today in India, are we ready for all of this? So there's sort of a debate going on. So essentially, therefore, the question then becomes, how do we convince them? Because not being able to put in flexibility doesn't seem to be a smart option, right? Projects need to be flexible, all right? So you can't sort of say, okay, because there are concerns with corruption, let's go back to rigid inflexible contracts because we know that they don't work, right? So how do we sort of convince them? And that's where, in fact, Carlos Cruz was here at IIT Madras about 6 months ago. Some of you might have met him, not sure if you have. So Carlos talks about, well, some of this is similar, and he has, all of these sort of kinds of options that you can have on projects. You can, an option to expand the scope, expanding is the going from 3 stories to 6, option to contract, so going from 100 MLD desalination to 50, option to abandon, option to defer investment. By the way, the Enron power plant also had an option built in. Remember, they didn't build all 2000 megawatts upfront, right? They built it in phases, etc., right? So that giving themselves option as the demand, grows it. So he talks about all of these, etc., classification. But what he does is he shows this methodology, right, where you can actually value the benefit of an option, right? You can actually have scenarios, right? And using those scenarios, you could see what happens in the inflexible case and what happens in the flexible scenario, and show that you're likely to get more benefits in the flexible scenario than the inflexible scenario. And all of this works because of a fundamental principle that's called the flaw of averages, right? So the flaw of averages is like this, right? So a canonical example, and again, this is part of Richard de Neufel's book, right? Let's take you have a hotel, all right? You have a hotel with 100 rooms, okay? You expect 75 people, 75 rooms to be occupied at a certain point of time, but that's an expectation, right? It can go up, it can go down, right? And let's say that's just a mean of a normal distribution. So let's say it could go up by 50%, it could go down by 50%. If it goes down by 50%, what happens to your revenues? It decreases by how much? So instead of 75 rooms, you get 37 rooms. Okay, it's gone down by half. What do you expect to happen to your revenues? decrease by half, right? I mean, half the people are going to come and pay, right? So revenues go down by half. Your the number of people wanting rooms goes up by 50%. What's going to happen to your revenues? Well, it doesn't remain the same, but remember you have a cap of 100 rooms, right? So it can't ever go beyond 100, right? So the point is, even though the distribution is symmetrical on both sides, right, the returns are not symmetrical on both sides, right? So this is sort of a fundamental principle which we call the flaw of averages, etc. The reason that sort of applies here is it sort of says, look, there are certain scenarios. So if you had n number of scenarios, half of which were this side of the mean, half of which that side of the mean, you average them, you'll get the mean, right? But the thing is, you don't have scenarios that are exactly going to be mirror images of each other, right? And very often you will end up with, if you do sort of a probability distribution, you might end up with more, just like in the hotel case, you might lose money, right? But you may not, in the downside, you may not gain as much in the upside. So if you have an inflexible contract, every time you have a downward scenario, you lose money. Every time you have an upward scenario, you don't necessarily gain back that money. And therefore, overall, your expected net present value is a little bit lower than expected, right? On the other hand, if you had a flexible sort of scenario whereby, for instance, you could expand the hotel from 75 rooms based on demand, etc., then you are possible, although the costs are higher, and we've talked about the costs of expansion being higher, your ability to service larger amounts of demand might actually exist, right? So this is essentially what he's tried to do here, and this is a very similar exercise that Richard de Neufel and Vivek Sakrani, who is a PhD student at MIT, did on the Delhi airport, right? And they said, look, Delhi airport, you have two options. You either build the whole airport, right, the huge airport that you see right now, okay, or you build a smaller airport and then you expand when the time is right, right? So do you need 85 gates today? Probably not, right? Will you need 85 gates 30 years from now? Possibly, right? But why build all 85 gates now, right? Why don't you build 40 or 50 or whatever, and then depending on when you need to expand, you expand. So they built one financial model which said 85 gates, and they had some revenue distribution, I mean some footfall. Number of people would come, number of airplanes, therefore number of gates that you need, etc. And they had sort of all kinds of, they sampled distributions, etc. And they came up with this so they came up with this, right? And as you can see, the net present value is a little bit on the left of 0, right? In other words, you're likely to lose money as a result of this. So then they said, okay, but scenario 2 is, you initially build only a small number of gates, and then if for 3 successive years, and remember you're sampling probability distribution, but for 3 successive years, if your demand increases, exceeds a certain threshold or something like that, then and only then expand, and your cost of expansion, is a little bit higher, right? But expand later. So you're expanding only when your demand is being met, right? So all the cases where you wastefully built the infrastructure have been eliminated, right? You're only looking at the cases where you are actually building infrastructure to cater to the needs, and therefore your cost is always being offset by some revenue. Yes, your costs are a bit higher, but they're always being offset by some revenue. Then when you do that analysis, and we'll look in the class at how we do that, look at where this finishes, right? The mean is there a little bit on the positive side of 0, right? So this is sort of a methodology that sort of says, let's model flexibility, model inflexibility, right? Let's randomly look at what are demand scenarios over 30 years. Let's randomly sample, Monte Carlo simulation essentially means do thousands of random samples, run your analysis and average and all of that, right? And oftentimes you will find that the inflexible scenario performs far more poorly than the flexible scenario. And so these are now techniques that I think we need to use to convince people that flexibility has value. I mean, that's the fundamental takeaway here, is that while people are afraid that flexibility can be misused, right, the point here is that flexibility can add value, because you can time your extra investment in this case to match with when you're getting demand, right? And as a result of which the returns on your project are likely to be much higher. You don't need to get into cases at the end where you're saying extend contract period, etc., right? So that's the this thing. So flexibility adds value, okay? Is this coming through? You guys are convinced flexibility adds value? And again, you'll be, when we do it on Excel, you can actually see it for yourselves, okay? Yeah, so flexibilities add value, but they come with risks, right? Negotiations can always be captured right? So I can say, yeah, let's have a toll review committee, but who knows who's influencing that committee? Remember the case of the Chad Cameroon pipeline, where there was a committee looking at the environmental management plan. 7 out of the 9 people were part of Idris Deby's cabinet, right? So yeah, I mean, you can have processes, but who knows whether they'll be captured or not, right? All of that. So I mean, these are the some of the challenges. Monte Carlo type simulation skills. We'll talk about this going forward. But anyway, the fundamental thing is, I think we need to realize that in the past we've had rigid contracts, rigid project arrangements, which always run into trouble because over a 30-year period, things will change, whether it's natural, political, technological, market, industry, whatever it is, right? The only way out of it is if you have flexibility, right? And we need to plan for flexibility in the contract. When you're designing the contract, you've got to say, okay, here are the eventualities that I can foresee, right? And therefore, I want to put in these kinds of adjustability, these kinds of options, and these kinds of negotiated settlements or whatnot, right? So this whole process needs to be thought through in the planning phase. So you develop a contract with flexibility in it, which can then last the test of time. And by the way, this is not new stuff. You've seen enough papers here. I've not done adequate research on this, but one of the areas where there's a lot of uncertainty is in oil exploration, right? Clearly, because you don't know if there's oil or not, and we've already seen a couple of case studies. So I'm told that the Norwegian oil industry in the, is it the Black Sea, whatever, the Baltic Sea, so the Baltic Sea, not the Black Sea. Okay, so anyway, up there, up north, oil exploration contracts have apparently a lot of flexibilities built into them, right? Because everyone realizes the uncertainty, right? Not only the geological uncertainty, but also uncertainties with regards to regulation, right? Suddenly things are possible, things are not possible. These are areas that you can go in and explore oil. These are areas that you can't. Markets change, the kinds of shipping trawlers and all of that changes. So much change that happened in that industry there. There's so much uncertainty that they have apparently evolved what we call hierarchical contracts. And there was an academic called Art Stinchcombe, who along with Carol Heimer wrote this book on hierarchical contracts and oil exploration in the, in sort of Norwegian offshore oil exploration. So these are ideas that have been there in certain industries. Question is, how do we bring them to infrastructure? Because that's one way of solving this problem of, I expected X, I'm getting Y, now I need to abandon the project. If you can reset the project, then that could help make a lot of sense.